Mi nombre es Roy. My name is Roy. I've been practicing the Spanish. Okay, it's an honor to be here. I'd like to share what Taipei Lab's been up to most recently. As many of you already know that we do urban robotics. Recently, we've been doing this quadruped robot. We do from station all the way to actual build. And we also work with TSMC on the indoor navigation, so making the robots can do things autonomously. And also lately we have Huang visited the lab. Huang, I'm not sure if you were here, but anyway, Huang was joining the robotic team and helping us with a lot of projects, and they are working on a open source bipedal robots project. Hopefully we'll share with the rest of the world. Whoever want to build or interested in robots can build their own robots. And we also, for the data team, we've been pushing the next generation of the agent-based modeling tool. We work with local governments to implement, to identify the most critical routes in the city for pedestrians. And we're also working with TDRI, Taiwan Design Research Institute, to develop a city design power index system to inform which city are more sort of mature in terms of design powers, and which will be a tool later on for world design capitals. And lastly, we just share our progress on City AI, which is a platform I will demonstrate later on the Dev Days hosted by Microsoft in Taiwan. And regarding City AI, I'm going to share some of the features, the latest feature that we did. Previously, last year, we shared how the City AI can perform basic data visualization based on natural language. And here, site selection. For example, give me an area that is within 10 minutes drive and nearest MRT station and open spaces, something like that. And the AI will understand the context, start to pinpoint where the center point is, and do a driving radius, catchments, 10 minutes, and identify the nearby MRT stations, and also do a buffer zone for close proximity, and do the same for green open spaces as well. And these tags, by the way, used to take hours or even days, required a whole team of data scientists or GIS experts. Now can be done by AI in the matter of seconds. A more sophisticated task like forecasting how the future would look like in terms of transportation, traffic, or social economics. For example, if a major development of a city, like a tech park, is done, how would that impact the surrounding traffic? With the pre-trained domain models, like in this case, we can train a traffic model to forecast the future, and once the user asks about the traffic, the AI will pull out the model and fit in the new variables and show us how the future is likely to be. In this case, it will show the surrounding of Suyin Beito, which is a new coming high-tech park in Taipei, and the traffic situation around the site. Something look like this, and the user can easily zoom in and pan, and also dial up and down the different time of the day to see the results. The technology behind this is a fundamental database that is spatial and temporal at the same time. We spent quite some time building this database, and it's actually global covered. And on top of that, we built the front end where human and AI can actually interact. What's most important is what happened in between. There are different AI agents, which is also a trendy topic right now. We have different AI agents, little minions, and based on the user query, they would do as they told, like tell me something about a city, and there's a PM agent dividing the task. There are other agents looking at the data and drawing the maps. What if, without the humans present, the AI can also conduct such tasks, like one data scientist continuously looking into the data and find something interesting, and some other agents making hypotheses. Oh, there might be a reason why this phenomenon. But there's also another scientist saying, okay, that's validated with statistics. Oh, it looks like some other reason, maybe some other domain expert agents, then inform human. Oh, we discovered the traffic jam is because of these rather than that. This is the why machine. And this is something that the lab and myself is very interested in. Why is why important? Let me share you a personal story. This is the actual story. Many years ago, I was chatting with a friend who's an urban planner, but also scientist. He's saying this, with data we can better describe, visualize what's happening, the city. With AI modeling, we can predict what's happening next. Once we can predict, we can better control how the city is evolving. Does it sound right to you? It makes sense, right? All the tech giants are proposing a similar idea, but something feels off. I couldn't argue at the time, but they don't come up with the other alternative, which, yes, we use data to visualize, we use it to depict because we are subjective. We always bring in our own opinion, and we shouldn't be shy away from that. Yes, we can predict, we can be a model, but it's more importantly to use the model to understand the correlation between different factors of a city. Because only when we understand better, knowing the whys, we can better innovate what is belong to the city, because every city is unique. They have unique DNA. Once we know better, we can create better cities. Oh, by the way, the city is going to be launching very soon, hopefully later this year. And if you're interested, you can sign up a sheet and let us know. Thank you.